Hello, in this video, we'll determine the matrix solution for logarithmic regression of this dataset. Here, we start with the equation, the logarithmic equation of this dataset, where we choose the scatter chart plot and display the equation as labels. We also show the R-square value. You will notice the curve is the closest fit to the available values of this scatter chart plot. And the equation is y equals negative 8.21 plus 5.15 ln x. And the value of r squared is 0.881. We will determine these values using the matrix operation. So we set this aside and start with the 1x matrix. Because the format is ln, so the x will be ln. It's a 1 ln x matrix. So we start with the 1 column, followed by the ln x column. It's equal to RA formula, ln of the x values. Now that we have 1 comma x matrix, we convert this to square and invert it using the Pijarina input inverse function, which is minverse and mult transpose of this matrix and itself. Next, we calculate the Pijarina output cofactor, which is equal to m mult transpose of this matrix and the y values. Now we can calculate the coefficient matrix, which is m mult this matrix times this matrix. So here we have the coefficients b0, which is equal to negative 8.209, and it is equal to negative 8.21, which is rounded off. B1 is 5.15, which is equal to 5.15, and there's an ln x. Now we can calculate for the estimated y, or the y hat, using this matrix, the 1x matrix, and the coefficient matrix. So here we have the y hat values, or estimated y. We can now calculate the residual sum of square, RSS, which is sum x squares of the differences of y and y hat. Next, we calculate for the degree of freedom of the denominator, which is rows of the dataset range minus columns of the dataset range. You have 7. Now we can calculate for the stay x, or the standard error of estimate, which is equal to square root of RSS divided by degree of freedom of the denominator. Now that we have the standard error estimate, we can now calculate the standard error value of the y-intercept, which is equal to stay x times the square root of this value. And we can calculate for the standard error estimate of B1, which is equal to stay x times square root of this value. Then we calculate for the regression sum of square, or ESS. Let's begin with the rows, or n, equal to rows of the dataset range, which is the population. Calculate for the TSS, or total sum of square. We need we also need the variance of the population. So you have n times the variance of the population, y. Now that we have TSS, total sum of squares, we can now calculate the regression sum of square, which is TSS minus RSS. So regression sum of square equals total sum of square minus residual sum of squares. Next, we calculate for the RSQ, or the coefficient of determination, which is equal to ESS, regression sum of squares, divided by total sum of square, or TSS. Our value is 0.8808, matches to the chart, or the R squared value of the chart. Next, we calculate for the F statistic, which is equal to uh, ESS divided by degree of freedom of the numerator, which is actually 1. So degree of freedom of the numerator is equal to columns. And since you only have one independent variable, so it's 1. So columns X. So we calculate for the F statistics, which is ESS divided by degree of freedom of the numerator all over RSS divided by degree of freedom of the denominator. This completes our metric solution for logarithmic regression analysis.